The ArmaLite AR-15 is a lightweight assault rifle designed by Eugene Stoner at ArmaLite in 1956. It was created as a scaled-down version of the company's AR-10 battle rifle. The new weapon was chambered for the intermediate .223 Remington cartridge and used a direct impingement gas system. It also featured a straight-line stock to help minimize recoil and keep the muzzle from rising. Weighing just 6 to 7 pounds unloaded, it was capable of selective fire at rates up to 750 rounds per minute. The design prioritized keeping things light for the soldier, allowing infantrymen to carry more ammunition by using smaller, high-velocity rounds. Facing financial difficulties, ArmaLite licensed the AR-15 design to Colt's Patent Firearms Manufacturing Company in 1959. This allowed Colt to refine the weapon and market it for military testing. Their efforts paid off when the United States Air Force adopted the Colt Model 601 as the XM-16 in 1962, followed by the United States Army purchasing it for service in the Vietnam War as the M16 rifle. The platform's modular construction, forged aluminum receivers, and use of innovative materials like fiberglass set the foundation for modern intermediate cartridge rifles. This design would go on to influence small arms development around the world. Colt introduced a semi-automatic civilian variant of the AR-15 in the 1960s, which saw extraordinary commercial success. Recent surveys estimate there are over 44 million AR-style rifles in the hands of United States civilians today. Its popularity is driven by its accuracy, ergonomic design, and adaptability for target shooting, hunting, and personal defense. However, while praise for engineering advancements that improved control and firepower in combat, the AR-15 remains a subject of cultural debate and legislative scrutiny. This is especially true regarding its semi-automatic features and detachable magazines, as it has been associated with criminal misuse, even though rifles make up only a small fraction of the firearms used in violent crimes in the United States. Eugene Stoner joined ArmaLite, which was a division of the Fairchild Engine and Airplane Corporation, in 1954. Serving as the chief design engineer, he led the development of innovative lightweight rifles. In the late 1950s, the United States military showed interest in small-caliber, high-velocity ammunition. In response, Stoner scaled down his 1955 AR-10 design to create the AR-15. The original AR-10 was a 7.25-pound select-fire rifle chambered in 7.62 by 51 mm NATO. For the new project, Stoner collaborated with engineers Leroy James Sullivan and Robert Fremont. The AR-15 kept the direct gas impingement operating system from the AR-10. This system routed propellant gases through a tube under the handguard to strike the bolt carrier key directly. By eliminating a separate piston, it reduced the weapon's weight and aligned the recoil forces with the barrel for better control. The bolt featured an 8-lug rotary head that locked into a barrel extension. The carrier also had a built-in gas piston element that vented excess pressure through side holes, which kept the action and magazine from getting fouled up. The rifle was chambered in .223 Remington, a cartridge developed from the .222 Remington to achieve higher velocity and a flatter trajectory with less recoil. The design focused on letting soldiers carry more ammunition and maintaining control during automatic fire, rather than relying on the stopping power of larger calibers. The construction emphasized both lightness and durability. It used forged aluminum receivers that were rust-proof and weighed about half as much as steel equivalents. These were paired with a fiberglass or plastic forend. Features like the straight-line stock, elevated sights, and a modular takedown design made the rifle ergonomic, easy to carry, and simple to maintain in the field. The first prototypes were built between 1956 and 1959. They incorporated lessons learned from the AR-10 to fix early issues with barrel wear, all while keeping the modular design and select fire capability intact. By early 1959, ArmaLite had refined the design enough to license the production rights to Colt's manufacturing company, officially taking the rifle from a prototype to a production-ready weapon. Following the development of the AR-10 rifle, chambered in 7.62 by 51 mm NATO, Eugene Stoner at ArmaLite sought to create a lighter, select-fire rifle. He wanted a weapon that could use a smaller intermediate cartridge to reduce weight and recoil while remaining easy to control. In 1957, ArmaLite and Stoner worked with Remington to develop the .223 Remington cartridge. This led them to scale down the dimensions of the AR-10 to fit the new round. This new design kept the core features of the AR-10, including the direct impingement gas operating system, the rotating bolt, and the inline stock configuration. However, the resulting rifle weighed about 6.12 pounds unloaded, making it significantly lighter than the AR-10, which weighed 7.25 pounds. The first AR-15 prototypes, known as the X AR-15, were built in 1958. They featured lightweight aluminum alloys for the upper and lower receivers to cut down on weight without losing structural strength. Early designs included a charging handle built right into the carry handle, and the first versions did not have forward assists. ArmaLite put these prototypes through rigorous testing. During one major evaluation on April 21, 1958, they fired 40 rounds per minute for 5 straight minutes. At least one prototype made it through this entire test without a single malfunction. This testing showed the design could be highly reliable during rapid fire. Still, some versions needed tweaks to the gas system and bolt carrier to work perfectly with the high-velocity .223 Remington ammunition. Between late 1958 and early 1959, the United States Army Infantry Board evaluated more prototypes. The new rifle showed better accuracy and less recoil than existing service rifles. This performance sparked further military interest, even though there was early skepticism about the unproven materials and the new cartridge. In 1959, ArmaLite was struggling. They faced financial issues, a lack of manpower, and limited production space. Knowing they couldn't fulfill massive military contracts on their own, they sold the rights and trademarks for the AR-15 to Colt. This deal also included the AR-10, giving Colt the chance to use its massive manufacturing power to refine and mass-produce the rifles. At the time, ArmaLite leadership simply didn't believe the military was going to adopt the weapon anytime soon. For them, getting quick cash was more important than holding on to an innovative but completely unproven rifle. Colt immediately started building the AR-15, aiming straight for military testing and export. Their first select fire version, known as the Model 601, was handed over to the United States Air Force in 1960 for testing at Lackland Air Force Base. Colt built around 300 of these rifles in the early 1960s just to get them into military hands. But they didn't stop there. Colt also started designing semi-automatic versions for the civilian market. With the help of the rifle's original designer, Eugene Stoner, Colt began aggressively marketing these guns to law enforcement and regular citizens. They heavily pushed the rifle's ultralight design and the fast .223 Remington caliber. Those early commercial rifles became the Colt AR-15 Model 01, produced from 1959 until 1964. They came with a 20-round magazine, a 1 and 14-inch rifling twist, and even though some military setups had select fire, the civilian models were strictly semi-automatic. Then, in 1964, Colt rolled out the Model 02. They updated the rifling twist to 1 and 12 inches to better stabilize a 55-grain bullet, while keeping the classic 20-inch barrel and fixed stock. These early guns paved the way for the famous SP-1 Sporter line. Mass-produced from 1964 all the way to 1982, the SP-1 featured that iconic triangular handguard and was built purely for civilian sporting use. The platform became so highly regarded that by 1963, even the United States Secret Service was buying Model 01 rifles to protect the president. Ultimately, Colt's strong commercial push established the AR-15 as a highly successful civilian firearm long before the military ever made it standard issue. In December 1959, Colt acquired the production rights for the AR-15 from ArmaLite. They paid $75,000 plus a 4.5% royalty and immediately began aggressively marketing the select fire rifle to the United States military. During 1960, extensive testing at the Aberdeen Proving Ground showed the rifle's clear advantages. It weighed just 6.25 pounds unloaded compared to the 9.25 pounds of the M14. It also had a larger 20-round magazine and a highly effective range using the 5.56 by 45 millimeter cartridge. Because of this, the United States Air Force ordered 8,500 units in 1961 for base security and special operations. The Army initially resisted the change, preferring the 7.62 by 51 millimeter M14. However, Secretary of Defense Robert McNamara ordered further evaluations, influenced by studies that favored lighter weapons capable of a higher volume of fire. In November 1963, McNamara approved an Army order for 85,000 XM16E1 rifles. This was an improved select fire version with a chrome-lined bolt carrier, though it lacked a forward assist. Under Project Agile, initial deployments had actually begun earlier in 1962. 10 AR-15s were tested in Vietnam by United States advisors and South Vietnamese forces. The weapons proved easy to control during full auto fire, even in the humid jungle environment. By 1964, United States Special Forces and Air Force units in South Vietnam received the new rifles, marking their official combat debut. Widespread Army distribution accelerated in 1966, replacing the M14 as American troop levels escalated. Units like the 1st Cavalry Division were already equipped by late 1965. The rifle was standardized as the M16A1 in February 1967. It incorporated minor refinements based on heavy combat use during major battles in the Ia Drang Valley. However, early deployments were plagued by serious reliability issues. Jams were common, made worse by unchromed chambers that quickly corroded in the Vietnamese climate. Gunpowder residue caused severe fouling, and troops lacked proper maintenance protocols and cleaning kits until mid-1967. About 90% of all failures were caused by spent casings getting stuck in the chamber. These problems, combined with rushed production and poor training, led to documented combat failures that tragically cost soldiers their lives. This sparked congressional inquiries and forced design changes, such as chrome-lined bores and improved gunpowder, which were introduced by 1968. Despite these early setbacks, adopting the M16 reflected a massive shift in military doctrine towards small-caliber, high-velocity infantry weapons. By the end of the war, over 5 million of these rifles had been fielded. The reliability issues with the M16 rifle during the Vietnam War, like frequent extraction failures from corroded, unchromed chambers and fouling after the 1967 switch to dirtier ball powder, were largely fixed through wartime solutions that became standard after the war. By 1967, chrome plating the chamber began, preventing pitting and sticking in humid environments. This was followed by full bore and chamber plating, which practically eliminated extraction failures when paired with issued cleaning kits and chamber brushes. Other improvements included stainless steel gas tubes to resist corrosion, hardened bolts for durability, and redesigned buffers to handle the faster firing rates caused by the ball powder. By 1970, the powder was reformulated to reduce residue buildup. These changes, along with mandatory maintenance rules, restored operational reliability by the end of the war. Still, the rifle's reputation for jamming stuck around because of early field experiences and a lack of initial training. Post-Vietnam evaluations in the 1970s refined the platform even more, adding a rubber buffer on the extractor spring to make case ejection more consistent in different conditions. The biggest leap came with the M16A2, adopted by the United States Marine Corps in November 1983 and the Army in 1986. This model addressed the accuracy, control, and sustained fire issues seen in combat data. The A2 featured a heavier barrel with a faster 1-in-7 rifling twist compared to the A1's 1-in-12 twist. This stabilized the new M85-5 cartridge, improving long-range performance and reducing barrel whip during rapid fire. The firing mode was changed from fully automatic to a 3-round burst to save ammunition and reduce muzzle climb. At the same time, reinforced receivers, a case deflector for safer casing ejection, and interchangeable plastic handguards improved durability and heat resistance. The sights were upgraded to fully adjustable rear apertures, handling elevation and windage up to 875 yards with a square front post for precise targeting. The stock was also lengthened with a new butt plate for better ergonomics. These changes, paired with the improved ballistics of the M85-5, drastically increased the number of rounds fired between failures, pushing it way past Vietnam-era levels. Field tests confirmed this enhanced reliability across various environments. Commercial AR-15 variants from Colt included similar features, like chromed parts and modular handguards, giving civilian users the same benefits without the selective fire mechanisms. Overall, these post-war refinements transformed the AR-15 derived design into a standard for modular rifle reliability, prioritizing real-world testing over past logistical mistakes. The ArmaLite AR-15 uses a unique gas-operated rotating bolt mechanism. Designed by Eugene Stoner in the late 1950s, this system operates quite differently from older rifles. Instead of relying on a standard external piston, it taps a portion of the high-pressure gases from the barrel and directs them straight into the bolt carrier assembly. The inside of the carrier actually serves as an expansion chamber, essentially building an inline piston right into the carrier itself. When the 5.56 by 45mm cartridge is fired, it generates a massive chamber pressure of about 55,000 pounds per square inch. As the bullet travels down the barrel, it passes a small gas port. High-pressure gas bleeds through this hole and travels back through a stainless steel tube that runs alongside the barrel, all the way to the gas key on top of the bolt carrier group. Once inside that hollow space, the gas expands rapidly. It slams into the rear of the bolt with over 1,000 pounds of force, overcoming the locked bolt and shoving the carrier backward at speeds of up to 20 feet per second. As it moves, a cam pin rotates the bolt counterclockwise, unlocking it from the barrel. This unlocking happens in just 1,000th of a second after the bullet leaves the muzzle, ensuring the pressure has safely dropped below 15,000 pounds per square inch. As the carrier group travels backward about 3.5 inches, the extractor grabs the spent brass casing with 20 to 30 pounds of force, and the ejector flings it clear at a 3 to 4 o'clock angle. The backward momentum then compresses a recoil buffer spring hidden inside the stock. Once this spring, which has an average tension of 10 to 12 pounds per inch, absorbs the energy, it drives the carrier back forward. On its return trip, it strips a fresh round from the 20-round magazine and pushes it directly into the chamber, locking securely back into place. In semi-automatic fire, this entire cycle can theoretically repeat between 700 and 900 times per minute, limited only by the trigger mechanism. Eugene Stoner made sure to point out that this was not a traditional direct impingement system. By using controlled expansion within the carrier rather than blasting gas directly onto moving parts, the design reduced carbon fouling and kept the rifle incredibly light, weighing under 7 pounds when empty. While people still commonly refer to it as direct impingement, it actually functions more like a short stroke piston. This internal gas dynamics allowed prototypes to fire over 10,000 rounds with almost no issues during testing in 1958 and 1959, proving that with the right ammunition, like the .223 Remington, the design was highly reliable. The ArmaLite AR-15 utilized forged 7075 T6 aluminum alloy for its upper and lower receivers. This material choice was influenced by Eugene Stoner's background in aircraft engineering, prioritizing weight reduction over traditional steel construction. This alloy provided sufficient strength for the rifle's operating stresses while contributing to an unloaded weight of approximately 6.35 pounds, allowing soldiers to carry more ammunition. The barrel was made from steel, typically a 4140 chrome moly alloy, with the bolt carrier group and other high-stress components also using steel for durability. Non-structural elements like the buttstock incorporated phenolic composites, and early handguards used fiberglass-impregnated resin for heat resistance and lightness. Modularity was a core design principle, achieved through the rifle's split receiver architecture, where the upper and lower receivers connect via 2 push-pin takedown mechanisms. This allowed quick separation for cleaning, barrel replacement, or reconfiguration without tools, supporting field maintenance and adaptability to mission needs. The modular upper receiver housed the barrel, bolt carrier, and charging handle, permitting swaps for different lengths or calibers in derivative systems, while the lower contained the fire control group and pistol grip for standardized ergonomics across variants. Ergonomically, the AR-15 featured a straight line stock and barrel alignment to channel recoil directly rearward, minimizing muzzle climb and torque during full auto fire, compared to curved stock predecessors. A separate pistol grip provided a natural hand position for trigger control, complemented by an ambidextrous thumb selector switch for safe, semi-automatic, and full auto modes. The inline design, combined with the lightweight materials, reduced shooter fatigue and improved controllability, aligning with Stoner's goal of a rifle suitable for extended infantry use. The AR-15's pistol grip is typically hollow, with an opening at the bottom, often fitted with a removable cap. This design allows for storage of small items such as spare batteries for optics, hearing protection batteries, or even extra ammunition. In the original ArmaLite design, the pistol grip also served as an attachment point for the sling with holes or features to route the sling, though this was later changed to a conventional swivel on the buttstock per military requirements. Modern aftermarket grips often enhance this storage feature and provide ergonomic improvements. The ArmaLite AR-15 is chambered in .223 Remington, a cartridge developed in the late 1950s by Remington Arms specifically for the rifle's design, featuring a 55-grain boat tail bullet optimized for high velocity and flat trajectory from lightweight infantry weapons. This caliber provided a balance of reduced recoil, higher ammunition capacity, and sufficient terminal ballistics for intermediate range engagements compared to full-power rifle rounds like .30-06. The key specifications of the original ArmaLite AR-15 include a 20-inch barrel length, an overall length of approximately 39 inches, and an unloaded weight of approximately 6¼ pounds without a magazine, emphasizing the rifle's lightweight construction using aluminum and composites. The barrel featured a 1-in-14 rifling twist rate, selected to stabilize the light 55-grain bullet at high velocities while minimizing barrel wear and bullet spin-induced instability. The ArmaLite AR-15 and subsequent AR-15 style rifles load via detachable box magazines inserted into the magazine well. The bolt carrier group can be locked to the rear using the bolt catch, which is automatically actuated by the magazine follower when empty. Standard procedure in many contexts involves locking the bolt back, either manually or after emptying a magazine, inserting a loaded magazine, and then releasing the bolt to chamber the first round. Alternatively, magazines can be inserted with the bolt forward, followed by racking the charging handle to chamber a round. With a fully loaded magazine and bolt closed, insertion may require significant force due to the need to compress the magazine spring further against the obstruction of the bolt. This is a normal characteristic of the design and not a defect. Users often report needing to slap the magazine home. Locking the bolt back first eliminates this resistance, making loading smoother. The CAR-15 family, introduced by Colt in 1966, was a series of compact, select-fire versions of the AR-15. They were built specifically for special operations and close-quarters combat during the Vietnam War. The XM177 Commando model had an 11.5-inch barrel extended to 15.75 inches by a 4.25-inch flash suppressor. It featured a collapsible stock and used 20 or 30-round magazines for 5.56mm NATO ammunition. Unloaded, it weighed just about 5.2 pounds. The United States Army bought around 2,815 units of a related version, while the Air Force called it the GAU-5A for their aircraft units. These carbines were heavily used by special operations groups who relied completely on the CAR-15 for covert missions behind enemy lines. Its lightweight design made it highly controllable in the dense jungle. After Vietnam, the CAR-15 concept shaped future military rifles like the M16 and M4. While Colt eventually stopped making this specific modular system, its elements lived on in later weapons. The original models remained highly valued for aircrew survival, giving downed pilots a compact way to defend themselves against ground threats. An updated variant called the XM177E2 fixed early issues with bullet speed caused by the short barrel. The short barrel had reduced the bullet's velocity to around 2,750 feet per second. The new version improved ammunition compatibility, making the weapon much more effective in thick vegetation. In law enforcement, the United States Secret Service was an early adopter. They equipped agents with Colt AR-15 rifles by 1963. You can even see Agent George Hickey holding one in the presidential follow-up car during the events in Dallas on November 22, 1963. The Air Force Security Police also received their first AR-15 rifles in May 1962, a move championed by General Curtis LeMay to help defend military bases. By 1964, Colt began marketing semi-automatic AR-15s directly to law enforcement, proving the weapon was highly useful for urban patrols and tactical responses. Today, police mainly use semi-automatic versions as standard patrol rifles. They are chosen for their adaptability, medium-range accuracy, and ability to be deployed quickly during active shooter situations. This reflects a major shift toward rifle-equipped officers that began after several high-profile incidents in the late 1990s. These modern rifles typically have 16 to 20-inch barrels, adjustable stocks, and rails for mounting optics. They are designed to keep officers safe and give them an advantage over armed suspects, all without the fully automatic firing mode that is restricted to military use. Civilian AR-15 rifles are semi-automatic firearms derived from the original ArmaLite design. They lack the selective fire mechanism of military variants and are configured for applications including target shooting, hunting, and self-defense. Initial civilian production began with Colt's AR-15 Sporter models in the 1960s. These featured 20-inch barrels chambered in .223 Remington and fixed stocks compliant with federal regulations. These early models emphasized lightweight construction and modularity, allowing users to attach slings and basic iron sights, though customization was limited compared to modern offerings. The expiration of key Colt patents in the late 1970s, especially those covering the direct impingement gas system around 1977, opened the market to competing manufacturers. This spurred significant diversity in AR-15 style rifles. Companies like Bushmaster, DPMS Panther Arms, and Olympic Arms entered production in the 1980s. They offered variations with adjustable stocks, shorter 16-inch barrels for carbine configurations, and improved ergonomics like pistol grips. This proliferation led to over 300 manufacturers by the 2010s, producing rifles under names like M4 clones or modern sporting rifles, with production exceeding 16 million units in the United States by 2020. Today's civilian configurations utilize the AR-15's modular rail systems, such as Mil Standard 1913 Picatinny or M-LOK for mounting optics, lights, and foregrips. Barrel lengths range from 7.5 inches for pistols that require stabilizing braces to 24 inches for precision varmint hunting. Gas system variants include carbine length for maneuverability, mid-length for balancing recoil and reliability, and rifle length for longer barrels to reduce wear. These are tailored to specific uses, with calibers extending beyond .223 and 5.56 NATO. Options now include 300 AAC blackout for suppressed subsonic operation and 6.5 Grendel for longer range accuracy. Manufacturers like Daniel Defense, BCM, and Ruger with their AR-556 emphasize forged receivers and chrome-lined barrels for durability, often exceeding military specifications. Virtually all AR-15s not configured for sale in states that ban certain features have threaded barrels, and boutique firms offer competition triggers. This diversity comes from the platform's open design, enabling users to assemble 80% lowers into custom builds under federal guidelines prohibiting fully automatic fire without NFA registration.